So presenting stop trading security for predictive power, retrofitting diagnostic capabilities for in-place AI systems in electrical grid operational technology, OT, Emily Soward. Over to you.
Hey, thank you. So I want to thank everybody for being here. Out of all the places you could have been on a Friday, this was a little hard to get to. I was on the train or around the train for 14 hours yesterday, and we love critical infrastructure. So who am I? Why should you care about anything I have to say? Besides this being a dump of half of my resume, I'm the Chief AI Officer and founder of Applied Threat Intelligence Group. We are our own boutique firm. Sorry, that threw me off. I was really surprised. I do a lot of work in AI systems, retrofitting, re-engineering, re-architecting. I have over 15 years in the field. I did not just arrive here a couple of years ago, though welcome if you did. And most relevant to this talk is this is an experience-based talk. So I have an informed perspective on the topics I'm talking about, though I'm not going to be talking about specific clients. So I pulled like newspaper articles or like pictures of NERC, FERC, etc. But you can get the general idea. Catch me in the hallway if you want gorier details. Today we're going to be talking about my call to action: stop trading security for predictive power. We don't need to be doing that. We're going to start with a disclaimer technically, because I will be talking about client compliance and legal issues a little bit. We're going to talk about what investigations need to look like for AI systems, and then retrofitting at a very high level. Again, this is a packed 50 minutes. I'd appreciate questions at the end in the hallway. I'll be here all week. I'll be here all weekend. I'll be in the bar. I'll be around. So please hit me up. This is one of my favorite subjects. I am not a lawyer. I am not your lawyer. Most pertinently, if you're going to use any of this information somewhere, we good? I will just not move. I think I too forcefully slammed it. Okay. Do your own due diligence. Again, don't just plug ideas I gave you into the electrical grid without any thought. I would not like for you to do that, nor would our firm. So today, the whole point, stop trading security for predictive power. The reason to give this talk is really I want to convince you that we don't have to trade off. You don't have to install subpar systems to have AI. I want to debunk a lot of false beliefs. I want to develop a shared point of view, and I also want to share my experience and make sure that you can benefit from that. So scope today is pretty high level because this is a huge amount of effort. We're going to be talking about the false dichotomy between we have to have security or AI. That's not true. We're going to be talking about some of the complexities in using AI in power and utilities. There's a lot that you can read on the internet. There's a lot that I'm going to talk about outside of that. Without going too hard in the paint on just telling everybody secrets. I will be talking though about how utilities are using AI with a couple examples, and then I will be kind of talking about some of the controls retrofitting that's needed. Again, this is not super technical though, so I'm not going to be like, oh yeah, if you do this specific tool, or if we launch a brand new AI system, because I don't believe that we have to do everything new all the time. I'm also not going to talk about anything that's just extending the grid. These are all OT systems, things that are actually critical infrastructure rather than we want to make SOC analysts' lives easier, which of course we do, but we're going to be talking more about demand generation, that sort of thing. Also not going to talk about specific exploits or unpatched vulnerabilities, but I am begging you to talk to me in the hallway if you need to know things. All right, here we go. Power and utility companies, they're selling energy. Right? They're delivering electricity to your house. To here, the lights are on. It is actually, if you've worked in this space, which many of you have, who's worked for a utility, worked in electrical? Who's done it? Anyone? Oh, sweet. Okay, nobody will admit that they've ever worked in energy. I love it. So some of you might have and just didn't want to say so, but all right, so this will be good. They don't actually have a goal. If you're a utility company, you don't have the goal necessarily to protect the entire United States from nation state adversaries. You have the goal to get energy to someone's house at the right cost that your business can sustain. So there's a tension here that has led to kind of what is happening in the industry. So they have a variety of sources. This is companies like, who sells you your energy here? Duke? Do you guys get Duke, Savannah? Georgia Power. Okay. So, there's a lot of them, right? So, but your power company, literally your utility, right? So they're getting their generation from different sources. Not every utility that distributes electricity to end and consumers actually generates their own power. Some of them buy it on a commodity market. That's really popular in Texas. Not all of them have the same organizational structure. Not all of them have the same model of doing business, but the one thing they're all doing is trying to get you electricity at a price point that makes some money. And that is why this is the way it is. We all know about Salt Typhoon, Volt Typhoon, Star, like Asterisk Typhoon. But what needs to be pretty well understood is that utilities do not have a ton of money to protect America ahead of making sure that they serve their business. So, we're going to go through some myths and facts. This whole thing, I restructured it as myths and facts. So, myth one is just a chat bot. It's just funny jokes. It's not that serious. We're not going to use AI. I'm sorry that I have to walk everybody through this. As so much of my time I spend talking to people in security is convincing them that AI is real. It's been around for about 70 years. We started in the 1950s. AI is any human-like task performed by a computer. Trust me, I have a distinguished master's in this. Was that me?
Yes.
Okay, I don't know. I give up. But so you can say that some lady who has a master's degree in AI told you that it's been around for 70 years. Then we came up with, let's use some mathematical models or machine learning. We're going to give a bunch of data to a computer and we're going to see what trends and ideas it spits out. Then we came up with deep learning, which is roughly speaking just a subset of ways to do math to data. Then we came up with more subsets of ways to do math to data. We're like, let's get a bunch of different data and build these like bigger models that we can then like fine tune for different things. By the way, this is like the 2000s, right? We're up into the 2000s. So machine learning, 1960s or so. Deep learning came first. It's interesting. Large language models, we used to just call them language models, but now we have big ones. Those kind of started becoming popularized in 2020, thereabouts. And then in 2022, ChatGPT came out, and that was not the very beginning of commodity models. You could still get models, for money, but, vend it as if it's a utility to you. But the most recent iteration of, all these LLMs and, Sora is the Sam Altman social media network where you can make fake videos of funny things. All of this kind of like commodification of AI, the computer's going to do human-like tasks is the pretty new part. And so that's the part where everybody's really hyped out and tired of it and they don't want to hear anymore and they're very sad. We could say that, AI has been around for 70 years. Commodification has been around for a little bit less time. It's been very, very hot. Depending on how you feel about Gartner or if you've ever really heard of it. Hopefully, there's some of you in the room who don't know what Gartner is and you think gardening. Awesome. We're in like the trough of disillusionment for a lot of people, but AI has been around for a long time. Every time we lose funding from the government, we just call it a different thing too. So that's how we got cognitive science. Anyway, so we could have called this commodification process deep fakes for business, but that doesn't sell as well. Or we could have called it like spoofing as a service, but that also sounds negative. But there's a lot of value in some of the tasks that we've solved, but we didn't just come here. So the thing you need to know also is like, we've walked through all of these kind of like technical history of how we've implemented AI systems, but the task performance is the thing, right? So if I've got, I want to replace every word in a document and, make it say cat instead of dog. I could use sed on the command line for free of like every computer. I could use my brain free inside my head. I could use a word processing software. I could have Gen AI do it, right? But the thing that I'm really going to care about in the AI side is not like, have I got the coolest model with the best benchmarks? Is it the nicest thing? Did I get the freshest, hottest AGI model or whatever? It's how well does it perform, right? If it starts to like replace cat with dog or dog with cat or cat with banana or whatever, it's not going to be that useful. Myth, AI is a fad. It's magical. Nobody understands it. It's probably going to go away. I don't have to think about it. However, in utility companies, they don't really innovate anyway. False. We've got over 90% of organizations that want to use AI since 2019. I remember being in this industry back then. We were like, hey guys, we think you could do something pretty neat. Right. So that was like 2019 is arbitrary because that's when I had the first time cared about a number. But we were trying to get people to use AI for different tasks, and now everybody wants to. All right. So, and in OT specifically for the electrical grid, it's over 20 years. This is just what I've seen. I know it's more than that, but I don't have a number for that, and I'm not going to lie to you today. That's not on the agenda, unless it's a funny lie. That's a joke. All right, myth. There's no impact from commodification of models on the threat landscape. Super false, actually. So we just gave a talk, myself and my business partner, at MITRE on AI weaponization. I encourage you to watch it. It's recorded, but I'm going to give you the highlight reel just in case you don't want to spend 16 minutes of your life doing that. So threat actors are just like us. They're using AI to improve their ability to send phishing emails. A phishing email, and spear phishing particularly, is just really fancy sales emails, right? So like if you're using sales emails with Gen AI, and you can imagine they're doing it too, they're also connecting all of their C2 tools and all of their, like Wireshark and whatever to MCP, and like making these like amazing, like attack machine kind of technology. So they're using it. Adversaries are benefiting from it. There's an increased attack surface as we all add AI tools to our organizations that we don't really totally understand. There's some supply chain impacts. I encourage you to watch the talk, but where we got more into it. There's some gaps in tooling and defender knowledge. And then there's finally this kind of effect of the fog of war. Everybody's doing it. Nobody knows what's going on. Everywhere I go, like I was at dinner with my husband for our anniversary, he starts talking to me about AI. There's no reason to do that. Anyway, so this is, look, we are in a place where adversaries do have an advantage, possibly. I'm not going to say it's asymmetric, because asymmetric relevant to what, but they're not plagued by ethics teams and regulations and fear when it comes to stealing your stuff. So we also don't have a lot of good understanding of what they're doing exactly. I'm sorry that there's a video over the last part of that says it's nascent. So our understanding is nascent. MITRE has the kind of attack framework, and then they have like a derivation that's called Atlas. We only have 33% coverage. If I didn't put the slide in here, but I think it's just later, they're all broken. So talk to me if you want to know how they are all broken. So we don't have really any mitigations for 130 techniques. I know there's more of them also. But we're just beginning to understand the adversary, to talk about the adversary, to figure out what's going on. So this is a very fast-moving space. So they're using AI to change security economics. They're improving faster than we're improving. There's also geopolitical issues, climate and weather science divestments that, don't help us when it comes to like, well, we need to know what the weather's doing so that we don't blow up our infrastructure. This is generally an issue. Myth: AI cannot both be performant and meet security and compliance standards, but that's fine because it doesn't matter. We don't care about that. It's okay. Well, turns out, no, it's not okay. Everything is broken, like I said, from MITRE Atlas mitigation. So people that I've been talking to are going to like fallback methods of like, oh, I know a guy and he told me how to fix this one problem, or like I read somebody's cool blog, and that's kind of where we're at. NIST AI on 100-1 is not, it's mostly documentation based. ISO AC 42001. If you haven't heard of this, don't worry about it. Who cares? Right? Like, this is just like, compliance nerd stuff. But the important part about this is that most of the stuff that we've thought of to do isn't going to meet the needs. And the legal and the regulatory space is out in front of the compliance space. So like if you're a utility and you're not like a scholar of problems with computers, and you're like, okay, well, where's my paperwork on like how to figure out what's going wrong? There's just nothing. So it's a pretty big issue. It's pretty common now that there's a lot of lawsuits. There's been some historic lawsuits. Not a lot of utilities get involved in this, right? Especially like when it comes to brand risk and stuff like that. But there are some things to look out for in terms of this, because of just how hot this space is. So, knowing that you don't want to use something that could become controversial is something people care about. But overall, we could be performant. We could meet security and compliance standards, but the guidance we have and the kind of the market isn't doing it for us. So I will still argue that you don't have to trade security for AI. But there's a perverse incentive here in that vendors benefit from telling you that nobody understands it, so just install our software, right? Because if nobody understands it and it's like an act of God happened to my computer, right, then nobody's really liable to do anything. So I'm not saying that that's happening. I'm just saying that there's a lot of challenges here. So let's talk about using AI in energy. Myth. All we need is more ideas. If we were just more innovative, if we just thought harder, then we could fix the grid. It turns out that even the largest utilities have challenges operationalizing smart grid, other things that use AI. I'm not going to go into this. I promised I wasn't going to talk too much about smart grid, but I've been in utilities, even large ones, where they're like, yeah, well, we've got all our smart meter data. It's over there. We don't use it for anything. It just comes in. We just have to store it somewhere. They're not able to do anything with it because of all the reasons I just mentioned why it's too hard to operationalize this data. Like maybe it would be nice if we could dynamically change, the delivery of electrical energy to houses based on what my refrigerator tells you. But it's very difficult to do in practice. It's kind of diving deep into the weeds. Remote sensing UAS, there's some actually really good work here. This has been going on for several years. So PG&E is, I know pretty well what they're doing. They've also been in the news for it too, positively actually. And Florida Power and Light is another company that's doing UAS for their inspections. But one thing that I know PG&E has also additionally done, they talk about in this article, as well as some other places and patents, you can really sneak around and find out what people are doing that way. If you wanted to, right? So validate my claims if you want to by looking at patents. But there's a lot of things that they're doing to use computer vision to also be like, oh, is this C-hook corroded? Things like that, things that are significant. So this is a use of artificial intelligence. We're using computer vision. We're using a computer to look at a picture that we took with a drone and say, does it have, broken infrastructure equipment or like not broken infrastructure equipment in it. And so there's a lot of excitement in this space. There's even regulatory changes. Some of the challenges though is it's really difficult to model the variety of these environments. When we're talking about how we do security here, making sure that we have adequate data, right? Do we actually want to have pictures of all of our assets in some computer system? How important is that system to protect now, right? Because we used to send linemen out who were like pretty tenured, pretty seasoned. They would go walk the line, they'd look at it and they'd be like, okay, looks good to me or doesn't look good to me. And it's actually the IEEE has a standard for like all this stuff, and they'd write it down on a piece of paper. And so the knowledge of what exactly all the grid infrastructure looked like, all the access paths, all the access points, everything there, what it looked like under different times of year, different conditions, all of that was like in some, usually a man, like in his brain, right? And so we have to kind of beat him with a wrench if we want to figure out where this stuff is. Now I just have to break into your computer. So I don't do that, right? Like I'm not breaking into the utilities, but this is kind of a change in how we're thinking about hosting. There's also some of the kind of training and awareness piece, insider risk piece, right? If you are someone who has access to these volumes of data and information, if you're someone who has access to all of the telemetry coming off of, different devices, different network sensors, that sort of thing that we're now using for grid management, making sure that you have strong compensating insider risk programs is pretty important. I did have a great conversation with someone at a utility where they were like, well, what if somebody uploads, like fake images to the endpoint? And I was like, we have a way different problem that AI is not going to solve for you. Like, I understand like maybe data poisoning could occur, maybe data or model poisoning is a thought that you have. But like if you built all these like specialized models of electrical grid components, and the problem is the one inspector who's gotten this far in their career that they're even allowed to look at this stuff so far, like you are end to end gone, my friend. So then we, then we pick some different controls. So there's also some regulatory challenges. There's a lot of things where, you might need some even chain of custody because you have to treat this like evidence. So chain of custody being like, I know where the pictures were taken. I know who had access to them at all times. There have been some funny catch me at the bar stories with trying to keep the people who are allowed to inspect from deleting things on accident because they're not the best at computers. But it is what it is. So I talked briefly about like when we changed the method of inspection from like it's some person on an ATV driving around looking at the grid, or walking around looking at the grid. They're writing it down on a piece of paper, that sort of thing, in terms of how the data is captured. But also, what if we're wrong? What if we like don't identify some issue or fault, right? One thing it does do though that's kind of cool is once you have images, maybe you want this, maybe you don't. But once you have images of all your infrastructure and you have, computer-based categorizations of, where the assets are at risk, you can actually start doing more than using a divining rod. Since nobody agreed that they actually work in energy, I'm going to explain to you how they pick which things to fix. It's basically the oldest, crustiest dude, almost always a dude, gets a divining rod and a pivot table and is like, probably that one. So that's how all the maintenance budgets generally get allocated. But what you're leaving on the table there is like, okay, well, maybe we had more severe weather events than usual last year or the last 3 years or whatever in this part of the grid. And so we should, at least go do some flyovers and see if we have more corrosion than usual that could cause fires, right? So we're not necessarily doing that. We're just using most utilities are still just using that, like the oldest, crustiest dude. When you go to these places, it's awesome. I'm wearing my, as you can see, my Canadian tuxedo. This is fine to wear to work as an executive in energy. It's totally fine. Well, actually, these are a little bit fancy, but anyway, so all right. So one case, we're using it for inspections. You could say, okay, well, we're just replacing people, so maybe it's not that critical. One of the most critical cases where we're using this all the time, demand modeling or load models or load forecasting, whatever you're going to call it. So predicting what the demand will be for energy at all. So it's one of the main capabilities that covers almost every area of grid management. Everybody kind of needs to know what we think the amount of energy we're going to be using is. And so it makes it a pretty sensitive system to take care of. I have seen this running out of SharePoint. I have seen this, which isn't going well lately. I have seen this as a lot of VBA macros. That's pretty state of the art. I have seen this as a spreadsheet, just one spreadsheet. I've seen this as a program that I wasn't sure if it was architecturally more like a botnet or a daemon. But in general, this is an area where we have a lot of room to improve because if you look at, and I'll talk about Winter Storm Uri, which since you guys aren't energy people, I'll also explain what that is. It's the one where Ted Cruz went on vacation for a little bit of time. And then, so typically you're going to want to stuff your load modeling under the category of being a NERC-CIP-BS cyber system, which don't worry about it. It's just like, that's the one that they don't want to have to do. It's a bulk electrical systems. Oh, I forgot what BESS is. Just in a panic here. But so your utilities that don't have a lot of money are going to want to avoid getting this designation at all costs because it's the most sensitive systems. And so there's also down in Texas where we had all these unfortunate events where we found out that we're running the grid using models that didn't have safeguards on them. The SEC has started to like look a little bit more into rules around trading and publicly traded companies, that sort of thing. That's just the sense I have. It's not like I definitely know or like whatever, but so you might have a lot of standards you have to comply with, and this makes it difficult to build software, which is why sometimes people just forget where they put their software and hope for the best. Not the best standard. We also have perhaps PII, but some of the things that you could do if you were being really nasty, already published, like not knowing the load could cause problems, but also if I wanted to manipulate what the load forecasting looked like so that I had the wrong load forecasts and didn't take action, that can happen from as simply as I've seen they forgot to sanitize the weather data dates and like had like January mapped to July or something because it had the J or I don't know. And they didn't notice. But also you could try to manipulate how this worked and see if you could take out infrastructure. It's not the best thing to do. Don't do it. There's also, I wanted to go into some of the specific generation use cases. Just in theory, right? We might want to model the ability to generate energy at all. So like generators will have basically a label on them that says how much they can generate. And that's what a lot of people do. And so like you'll see somebody is like, oh, well, we're gonna like look at the supply and demand dynamic here as like we'll take the label off the machine, whether it can do more or less, we don't care actually. We'll take the label off the machine and we'll put a table together and we'll be like, if this facility is on, it's doing this for sure. And then over here is what my load is. So if you were a threat actor, you were trying to manipulate how that worked, you could take out a generator or you could degrade the generator or you could use wrong information or change the labels, that sort of thing. This is something that happens just when your data is a mess. But we might want to be more nuanced than what's on the generator for a lot of reasons and know that we actually have the right information. So getting into the nuance there exposes us to having more software, which is how we get cyber attacks in the first place. So you want as little software as possible. This is a joke. But at this point, okay, well, what did we generate under the same weather conditions? What is it typically used for? Is it on when it's cold? Is it on when it's hot? So these like older generators will come on and come off depending on whether it's the right fit for the moment. And so the modeling for this can be sophisticated or not very sophisticated. But it's, you know, when do we turn things on and off again? If you've ever done like cloud computing or like infrastructure, like, oh, I don't want to leave these VMs on because, you know, I call these people cloud bad. You know, make sure you turn the lights off. But we do turn the generators off when we're not using them. Okay. All right. So they're not innovative. They're super innovative. It's like actually amazing how effective and efficient these companies are. They just don't necessarily have the right culture, the right resources, the right number of people, the right number of dollars. You know, and I know it's hard for a lot of people seeing these companies rake in tons of money and be like, well, why can't they just fix things? It's really expensive to fix this stuff. Actually, it's crazily expensive. But they're pretty invested in AI already. All right, no real impacts from the operational environment have any effect on AI. I kind of told you how wrong this is. Weather specifically is changing how load modeling works. It's not a political issue, it's a fact. A lot of utilities do not have their own meteorologist, or if they're even a big one, they might have like one. They're like, oh, the meteorologist over here is like, they're like this person, they're like really cool person. Like you got to talk to the one meteorologist. So if that person sucks at meteorology, they don't know any better because they only have one of them maybe. So a lot of them rely on NOAA actually, or like, you know, governmental agencies, which this is just a reality. And so, you know, like if you're reliant on weather station coverage and there's not enough weather stations, or we got rid of a bunch of them because we thought the weather wasn't going to come get us, or whatever it is, or like you have a bunch of data centers close to the weather station, and then you have a bunch of residential buildings, which are a totally different type of load profile. Far from the weather station, we don't know how to accurately monitor them because we just literally don't know what the weather was locally, and that does matter. It's pretty limited to the industry how people are doing this. So UAS systems for inspecting grid infrastructure, you could imagine there's other people using UAS, but they don't necessarily talk to energy sector. But the sophistication of the techniques is very proprietary. Like a lot of these people work in secret. You're not going to talk to them. Even if you go work in energy, like for a while, you won't necessarily ever get to talk to the people who do the modeling. There was one job I did where they were like, we need you to come talk to them because if this guy who's been here for 20 years quits, we will not be able to function as a business. We don't know what he does. And every time somebody talks to him, he like hisses at them. Like, but we know is absolutely essential to the operation of this entire multi-billion-dollar business. But we don't know what he's talking about. So it's, you know, it's like that. It's that is how it is. Yeah, and so we just really don't know what buildings are doing. So I've got an example with like pictures, right? Because I know there's not a lot of pictures here. I'm very sorry for that. Like if I'm like illuminating a statue or like having traffic lights or whatever, there's like not going to be a lot of changes. Like you might see dynamic effects to like homes and health services, some of the utilities. One of the ways to tell that COVID had an impact and that we're rebounding from COVID is just how much energy is used in homes. Did we return to baseline? I've heard that we have, but you don't quote me on this. It's like a lot of hearsay. But, if there's a snowstorm or if it's too hot outside, I might use more or less energy. It seems smart, right? But plants and businesses, they're going to do whatever they're going to do, right? So if you're a business that sells ice cream and it's a hot day, you're probably going to use more energy. If you're that same business and it's a cold day, you're probably not going to do as much business. We could understand that, but it also gets a little bit weird depending on like, oh, can we even have people on site? Can we be running the plant at these times? Is it like too sensitive for our manufacturing to run at certain weather conditions? And let's talk about the storm. So, the dirty secret, while we're talking about the energy market, this is from this very good 100+ page report, hot wash of what happened in Texas when Ted Cruz went on vacation. That's how everybody knows it. Nobody's ever heard of Winter Storm Uri, but if I'm like, you remember that one time we went so hard for Ted Cruz, and this is not a political statement. That's just the only way that I can get anybody to know what I'm talking about. So, but like if the weather changes substantially, it impacts more than load. And so I wish I had a laser pointer, so I'm going to wander over. Okay, so here's the last two comparable events at all, and here's like what happened in Winter Storm Uri. If you look at how much load shed there was, it's more than what we had ever done before. We got much closer to 59. 59 is when the thing was like it's the storm. So we got. Sorry, I'm really emotional because I 4 minutes 33 seconds. Excuse me, I'm gonna take a drink. Very scary. I don't know why I cry about the grid. Don't worry about it. Well, yeah. Okay, we can't go into this though. I really will just cry. Okay. So I should have just put the number on there and be like, this is the number, and then just stand here like cool. Okay, moving on. So basically it had the effect of an unregulated hedge market. And so we figured out very quickly why we have financial laws for winners and losers on the stock market. We had some, because market price adjustments directly impact supply and demand in real time, right? So they are getting some fresh new laws next year. Good for them. Happy for Texas. All right, so in Texas, if you aren't familiar with it, they have their own grid, right? It's only connected to Mexico. So if they need help, they can't get it. That was a choice that was made. Nobody asked me about it. That's a joke. They didn't also ask me, but anyway, so they changed how they deliver and distribute energy so that they're basically dependent on financial modeling. And they learned why we have financial regulations as a result of that thing. Catch me outside if you want more information than you ever want. Okay, so another thing that can impact loads and attack surface, EV charging, batteries, and solar. We're trying to figure out how do we offset the impacts of fluctuations of load on the grid. How do we do battery storage? How do we do solar? How do we do, like from a general perspective, electric vehicles and stuff like that. The things that my partner could tell you if he was here, because he's tested these chargers, are horrifying actually, but there's a additional attack surface. Everything we add to the grid is another thing that can be attacked, right? And then also kind of notable is that solar peaks can shift the peak windows, right? So if you're in the energy space, the peak is like basically when we are using the most energy. Because solar energy often sits behind a meter, so somebody might have their own at-home personal solar. If you're like off the grid, quote unquote, you still might be connected to the grid, but you're generating your own energy. So if it's a cloudy day, you're going to be drawing more. So this is where the weather gets more important too. Okay, and then finally, large loads. I did generate this image. This is an example of something you can do if you use a lot of energy. There's a lot of concern, sufficient that we have a task force and an action plan and stuff like that from NERC on how to address large loads. Now, it's not just AI, it's also crypto mining. There have been some notable failures of grids, as well as brownouts of grids due to loads for crypto mining and other like high draw activities. So if you saw something, say something to NERC, I guess, because they are looking for vectors. Also, if you work for NERC, I know you're not here because federally you're not allowed to be, or you actually might be here, but hit me up. I have some ideas. But basically, the concept is the same as like if you've ever done actually network modeling is really analogous to like if you've done like IP modeling and stuff like that. You'll have these companies and they'll have their own IP ranges that are kind of behind a single public facing IP. The same thing happens with large loads where they'll be like, hey, I'm like, you know, a car manufacturer or whatever. And so I'm going to get all of my energy through 1 meter. And so then it really depends on what they're doing, what that load is going to look like, but we don't know what they're doing because it's behind 1 point. I have a funny story, actually. I live out in Oregon. I'm from Portland, Oregon. I was born there. We used to, and probably still do too, find residential marijuana grow ops. Now it's legal and cool out in Oregon to both grow and smoke and purchase and sell marijuana. But we used to find grow ops by seeing who is like, you're in a neighborhood, but you're drawing so much energy. This is a grow up for sure, right? So not that many people are actually growing their own tomatoes for salad, turns out. So power and utility companies are facing different challenges than they used to face. Large loads, weather changes, usage changes, cool Gen AI projects, all sorts of things, as well as like competition, global, you know, threats, that sort of thing. All right, so what do we do if we are trying to protect them? As investigators, AI systems have become a challenge. There is actually policy action from the current White House that specifically calls out AI incident response as a need. But the myth is that it's a solved problem. We don't need to think about it. You just encrypt the data. It'll be cool. I don't need to think of anything new. There's nothing for forensics, so I don't need to think about new types of evidence. There's nothing diagnostically. I don't need to have any other insights into what's going on. And there's nothing analytical so that I can like do threat hunting or anything else. False. Okay. So what's really different about AI, things to take to heart, it's pretty inconsistent in terms of supply chain security. It's often far worse from an SDLC perspective. So you're developing software that is significantly less well built than other types of software. People build websites and they tend to build them in the same way, and they use frameworks and they use tools and they do testing and there's an industry around it. And then for AI, it's like, hey, look, I plugged the, you know, the Wordle into the random seed into my, you know, client database, into, you know, Gen AI tools, into whatever. Like I've literally had to explain to someone why not to plug an LLM into their load systems so that they could predict the weather in the future. I was like, it's not, none of this will work the way you think it is. It's just not, but, you know, people get excited. Non-determinism is now what we're saying is, you know, so like we don't know what the answer is going to be. We're kind of like hand waving over companies that don't have a functional product security or product safety function. So they're not really thinking about giving you the features that you definitely need. There's a lot of gaps. There's a lot of confusion. There's a pretty high impact of compromise, all that sort of thing. So there's a lot of differences that make it, from an investigations perspective, I need to know what happened, when, where. I need to be able to create a timeline. And there's a lot of, especially for telemetry, I'm not going to ever be able to find certain things. So if you're a utility and you're trying to figure out, okay, well, when did someone upload all the cat photos to the UAS computer vision endpoint? A lot of AI tools will just not have controls for like who that user was. Even it seems unbelievable, but it is the case. So what's happening is a lot of folks are concerned for brand risk. There's a lot of resource hijacking, crypto mining happening. Data and information compromises. I'm a big stickler, and there's data and there's information. They're not the same thing. Anybody who has done information assurance knows what I'm talking about, and I thank you for that. But remote code execution, RC, reverse shells, privilege escalation, PE, with tools such as the model context protocol, LangChain, etc. And then there's regulator pressure on chemical, biological, radiological, nuclear, environmental data, and then CSAM. Because it's amazing how much AI-generated CSAM there is, actually, as well as risk to mission objectives for those things. So is it the case that we need to worry about it as an investigator? Many of the investigators I've talked to, they don't know where to find the logs. They don't know where to pull information from. Some of these things don't have logs. This Ray framework, this was an attack that was, it's famous because it's kind of like the first multi-company massive attack that we put in the news about AI. It's been happening for a long time, but this was targeting OpenAI, Amazon, Stripe, etc. Like, this is just one of the articles about it. There's a pretty broad scope of impact if you get taken down because of an AI security case. This is 31% of those cases that were reported to the IBM Cost of a Breach report this year were operational disruption. And if you are a grid operator, particularly, you can't have this happen. Like, we cannot disrupt the flow of electrical energy to people's homes over, you know, like cat girls generated from a tool that you installed because some vendor told you it'd be cool. Like, it's just not real. Like, I'm so serious. Some of this stuff, just catch me outside. It's fine. I don't mean fight me outside, but like, yeah. Thank you. But yes. Anyway, so this is also, the main point here is it's a high ticket breach vector as of 2025. So if you're the person named on your cyber insurance, you are the chief information security officer, and you are also the person who has to get yelled at a lot when you get breached or compromised through your AI systems. And so it's actually a real problem now. So the biggest call to action is, you know, develop incident procedures to at least know what you're doing. That include breach and disclosure, crisis management, multi-organization coordination, be able to call your vendors, that sort of thing. I have a lot more ideas, but I am running short on time, and some of the best value is just interrogating me about what I know. So, all right. So, where are the gaps? Traces are a big problem. There are tools that have been launched on the market where there is no ability to implement any policies you might have about non-repudiation because they lose the trace. Basically, what'll happen is somebody will be a user, they'll make a call to the system, you've provided them a user account, the user makes a call to a shared resource pool, the shared resource pool drops who the user's was, gets the resource from the pool, and if somebody had put malware in their payload, now there's malware in the pool of you know, like compute, and nobody knows who put it there because it wasn't connected to a user identity. So there's a big problem in some of these tools. Again, I'm not going to talk about specific exploits in this talk, but the scope of impact is massive. We might be in situations for remediation or investigation where we just don't know what data somebody downloaded and dumped into the thing. So particularly if you have a multi-class permissions model for who can even respond to incidents, think government, think, you know, agencies, that sort of thing. That's a challenge. Espionage is an actual challenge that we're seeing, and particularly in energy. You know, we know espionage is a problem, right? Like, we're not going to get into it too much, but basically the call out here is that if you've given somebody a bunch of cool data and information in a development environment, that's a softer target, usually, than, and we saw that with the Ray attack, that's a softer target than the prod environment, usually. So people will try to save money on development environment monitoring, thinking, oh, it's just dev, it doesn't matter. But then for AI things that they're developing, even if it's an application where you're not building the model yourself, people will pull in huge amounts of sensitive data. Late or absent reporting of these issues is a big problem in organizations. This can lead to conditions that are ripe for whistleblowing, but you know, whistleblowing is obviously a big step for people to make. They don't always make it. You might just not hear about an incident or an issue. And then missing procedures. Thank you for keeping me honest on time. I'm trying to speed up here. So, fact. One of the things you need to know as an investigator is on the wire. Sounds so cool to say that, right? Like the wire signature of someone genuinely asking a model for pictures of, you know, like utility infrastructure and someone who is an attacker with the inappropriate level of access that they've, escalated from some other system, it's going to look the same, right? And so a lot of this means that, like, we're missing telemetry. Everything's going to look the same over the wire. We don't know if somebody really wants those images for a good reason or a bad reason based on what they look like as packets, whatever. There's a lot of challenges for investigations teams right now. Okay, so retrofitting. Myth, we shouldn't fix anything. We shouldn't retrofit it. We should just put in brand new technology. Surely we'll get that from vendors. They are all the right solutions. I love this quote. My friends use this with their child. They're like, you'll go to breakfast with the pancakes you have, not the pancakes you want. Donald Rumsfeld has died. He was the former U.S. Secretary of Defense, and he had this fantastic quote, which I misuse and misattribute all the time. Sorry, Donald. You go to war with the army you have, not the army you want. We cannot just replace all these systems. We do not have the time. Some of them have been in place. The oldest one I've done is 23 years in place, and you can't just rip that out. Like, you don't even know what it's touching. It's dozens of systems rely on some of these things. I can't just snap into place things that need to be there. The challenge is that there's very few people who know how to do this. We don't know what we're doing necessarily. Like, there's a lot of competition to say to people who are grid operators that, yeah, our AI solution's awesome. It'll totally work for you. There's some expansion on some of these issues in a DOE report. So, like, we've talked quite a bit about the problems, but with the same tools we use today, we can make some updates, some changes, and we shouldn't replace current working solutions with just like plug and play magic AI tools. Myth, I can't figure out how to do it. There's no way to do it. False. Okay, step 1, figure out if you're a BAS cyber system or a cyber asset. If you don't know what that means and you've never worked in energy, this is not about you. But figure out if you have the highest level of requirements. Figure out what your tiering is in your organization. This all doesn't sound very technical, but this is also the first stuff you do, and then you figure out what your controls are from there. Do we even have the telemetry we need? I'm gonna wait for a sec. Sorry, you're just there you go. Welcome, thank you. So do we even have the telemetry we need? Telemetry is where you start plugging stuff in. You're going to want to go through these systems. If you have assets and you can't break into them and, add telemetry specifically on a single asset level, like a single database or whatever, you can bubble wrap it with a little bit of telemetry generated off of the bubble wrap. I do have some topics to watch. There's some issues that you'll see from the conflation of censorship, like, did we make the model not say dirty words, versus actual safety controls. These are not sufficient. You can't just put a filter between you and a chatbot and be fine. There's a lot of applicability of the tampering and forensic evidence issues for grid operators, actually, and for utilities. And where you're going to cut in is figuring out, like, from the very outside wrapper, what system telemetry for method calls of consequence from the top performing AIs. So, like, if I have a system where I'm sending images of my actual physical assets from drone flights to a computer vision system, I'm not going to put telemetry on the whole thing and just, like, capture everything that comes off of it. I mean, maybe you will, actually. Some of them do, but I'm going to say, like, request prediction. That's probably my top API that I use the most. And so I'm going to make sure that I have really good telemetry on request prediction, start working in just a little bit at a time. Develop end-to-end smoke testing and health checks to make sure that it is performing as expected. Otherwise, shoot it. This is a joke. Backups and rollbacks. I understand that everybody is going to be sitting here like, why did you just put me through all this? And you're going to be like, have backups. The basics, right? And then if you're adding new stuff, make sure that the logging and traces are right early on. I can go into more about this, but specific system to system, it is very specific how to do it. So the old way that we've been doing it is like, okay, I've got an application on a single host, and we can tell if the CPU is on or not. This is not sufficient for your investigations teams. Now you want to say, okay, even if the application is on any host or number of hosts or whatever, we can get telemetry about what the host is on or doing, the actions that are occurring, the events that are occurring. We know what the runtime looks like. We have granularity so that we can do reasonable diagnostics. That is the goal. Priority order, people think that their data is the most important. You actually want to get your hosts first because that's where people are going to get a foothold on you, or actors are going to get a foothold on you. Your development environments are pretty sensitive. They only come after hosts because the hosts are the ones that are most exposed. Your whole network level access, like if you're doing segmentation, I know that there's going to be somebody talking about segmentation. I want to hear that talk and why I'm wrong about hosts and then development environments and then network access controls. And then the last thing is data, because if you don't have these right, it doesn't matter where you put your data. Like your one data store of like all your cool operational information is important to protect. But if you are racing the attackers to figure it out, this is the order. So starting with GRC, operational risk, and where you'll see impact rather than your intuition to protect your data stores first. These are my recommendations, not all of them. And you can email me. The kind of main takeaway is that we can do this. It's going to be possible to do this. It's hard work and it sucks, but I like it. And so stop trading security for predictive power. Don't just plug in things to everything else. I didn't even shill my business, but I will if you want. Otherwise, questions. Thanks.
Got about 8 minutes for a couple of questions. Well, maybe a couple minutes actually. Paragraph 7. Oh, over here. Go ahead, please.
Is the newfound interest in AI companies
I think there's two questions here. One is there new interest? I think there is some new interest for sure. But there's also, they've been doing AI for a long time. So like the interest in integrating new technologies is coming from external pressure in large part. And like the belief that if we like plug these things in and they do what the vendors told us they're going to do, and like, it'll all be great, then I'll have like an easier way to operate my business. But the second thing is they also don't understand that they're already running AI because they're running AI that doesn't sound cool. And so they've got like that one analyst who has like a mission critical spreadsheet that runs the entire business, if you actually dig into it, validly an AI system, basically how they'll have it set up. So that's kind of where I see this side fitting in. Yes.
But you find the more renewed interest is on legacy side?
I've worked with some of the largest providers in America, and they're very interested in this topic. There's also smaller utilities that have less resources that are interested in more of the plug and play aspects. And the microgrid, private equity is actually, if you look at the we didn't even talk about like who owns what, but private equity is doing quite a bit of investment in the AI space as well.
I know Xander's specific.
Yeah. Yeah. A lot of them have a need to go find all their stuff and fix it that they're addressing, that I've seen. And then others are using AI as kind of a, oh, well, we've got to do something. Let me plug this in and try, right? We don't have an unlimited number of inspectors, right? So anything that we can do to reduce the burden. Yeah. You will be happy to know that the most mature AI policy I've seen yet in an organization was a very large utility. Challenge is implementation. So like you can't make your developers not install everything into everything else if you don't have line of sight to their environments. But I have seen actually the utility space and then also some of the more regulated industries, finance actually, are very, very proactive about like, regulatory risk, operational risk, that sort of thing. They'll have more mature solutions than they will have written down sometimes is also interesting. But if anything, these sectors, the folks that I've worked with have been slow to just fire hose AI into everything, which is kind of what you want, right? So fortunately, if they can implement it right, then it goes well. This is one of the highest risk sectors though. So if they get it wrong, people directly die. So yeah. So I just gave the talk at MITRE on AI for the year, which is cool. I think that's really cool. But I still am in shock that I did that, and I committed to them that I'm going to help. We should all talk to each other quite a bit at this conference. And I'm committed to you all to stay sober enough to have those conversations and then send them to people. But I got 8 tokens in my pocket. I don't know what I'm going to do. I'm not that big of a drinker, so I might just, but we have to do a lot of like cross-pollination, cross-communication. The biggest thing that people want in these industries is to hear what others are doing. They are desperate for solutions. So